So welcome all. Thanks for taking the time to join today. I'd like to provide you with a whistle-stop tour of the four major KMS setups you need to choose from when using AWS. But first, the obligatory marketing slide. Here at Fujitsu, we have four main focus areas: working with manufacturers to create sustainable, efficient production lines, supporting retailers in delivering a compelling, secure customer experience, enabling the healthcare sector to provide top quality care, and fostering trust in society through secure, accountable government systems. And cloud, via our hybrid IT practice, provides a basis for all of this. So with marketing achieved, let's move on to encryption, the topic of today. So why is this topic so important? Simply because we should always be encrypting all of our data. Encryption isn't just about preventing unauthorized access, the confidentiality part of the CIA InfoSec triangle. It's also about integrity, the I in the triangle, ensuring that unauthorized modification of our data contents is prevented. And in today's ever more challenging regulatory compliance landscape, encryption isn't just a good idea, it's also the law. Well, sometimes. And with all of that being said, I've often found that organizations focus so much on the encryption of the data that they overlook the management of the keys. And after all, there's no point locking a door if you leave the key hanging from the doorknob. It's a bit pointless. So let's start with the ground floor, the entry-level approach to encryption key management on AWS, which is the easy button, the default option, and the bare minimum any organization should be doing. So how does AWS KMS, Key Management Service, work out of the box? We start in our simplified diagram here with our data, for which we've hit the Automagic Encrypt button, and with KMS. First, a data encrypting key, or DEK, is generated, which is used to encrypt our data. Fair enough. A new data encrypting key is generated for every piece of data we encrypt, for example, for every S3 object, and managing access control lists for thousands upon thousands or potentially millions of data encrypting keys would be very impractical. So instead, KMS creates a second key. The key encrypting key, or KEK, is then used to encrypt the data encrypting key. We only need a very small number of KEKs, usually one per AWS service, to control access to as many data encrypting keys as required. This approach is known as envelope encryption. We spent a little time going through this process here as it's foundational to all the other KMS options. But what does this mean for us as AWS customers? For each of the KMS options today, I'll give you my top 3 tech details to know about, starting with default KMS is entirely owned and controlled by AWS. You don't see the keys and you never will. Those keys are stored in hardware security modules, HSMs, shared with all other AWS customers in the region. Naturally, these are entirely controlled by AWS as well, which makes everything super easy to use. However, AWS's KMS's approach to key management is 100% proprietary, meaning there are no tools that could decrypt the data outside of AWS. So the ciphertext, the encrypted form of our data, can only be converted to plain text, its original unencrypted form, by AWS. This last point remains true for all of the KMS options we'll discuss today. Let's summarize this by answering 2 critical questions we need to ask when choosing our KMS setup. The first of our critical questions is, who owns the key? This can be a very important one when speaking to your legal department or your compliance managers. And the answer, the default KMS, is Amazon, of course. You don't own it, you can't see it, and you never will. Given all of that then, when should you use the default approach? Well, it ticks the box anywhere and everywhere the other options don't. In many cases, the only way to encrypt data in AWS services is with KMS. And if there's no driver to use the other options here, which increase with cost and complexity as we go, this is your baseline. So now that we've established our baseline, what does the next level up look like? The next step up is what used to be called bring your own key. However, AWS presently prefer to call it customer managed keys, or CMKs, which changes our default setup in one particular area. Now, everything about the default KMS approach is the same. DEX encrypt the data, KEK encrypts the DEX, using the envelope encryption approach. But with one change. Instead of KMS generating the key encrypting key, you generate your own key material for it outside of KMS, and then import it into a customer managed key inside KMS, which means, unlike for our baseline before, we now get to see one of the keys. So how does this impact us? Whereas AWS took care of everything in the default setup, now we have some ops effort to handle. You have to look after the life cycle of your customer managed key material, including rotating it regularly, which was handled by AWS in the previous level, and the security and availability of that key material. So why would you take on this extra work? Because now you can revoke AWS's access to that key. CMKs enable us to delete the key material from KMS, which prevents access to any encrypted data whose data encrypting key is protected by it. And so long as you deleted just the key material and not the key object itself in KMS, you can re-import the same key material into the same key object later to restore access. This can be a boon for compliance where we need to demonstrate some measure of control over AWS's access to our encrypted data. So what does this change for our two critical questions? As far as ownership of the key goes, you now own the key material for the KEK, the key encrypting key. Naturally, you have to make that material fully available to AWS in order for it to be used, though. And as far as the compliance case for customer managed keys, for CMKs, the thing to look for is a requirement to own the generation and rotation of the key encrypting key. Typically, this comes up where there's a detailed entropy source specification for key generation given in the regulations you're aiming to comply with. And that is customer managed keys. Now, moving swiftly on to the next level, we meet Cloud HSM, AWS's hardware security module as a service offering. KMS has supported Cloud HSM integration for a long time. However, it can be quite an involved service to use, which has sort of made this option the awkward middle ground for KMS. Let's get into it. So everything about the data encrypting key, the DEX part, remains the same. The DEX encrypts the data. However, now, for the first time, the KEK, our key encrypting key, lives outside of KMS. Cloud HSM generates and manages the KEK, which, as before, is then used to envelope encrypt the DEX. As you can see, this is the first major change in our key management architecture, as it introduces a new key storage component beyond KMS. And that brings with it some meaningful compliance impacts. Starting with tenancy. At this level, we've moved out of the apartment block and into our very own house. Cloud HSM clusters are single tenant. Therefore, our key encrypting key is now stored in single tenant HSMs. And that brings with it some additional capabilities, like zero weight key deletion. When our key encrypting key is stored in AWS KMS, deleting that key object cannot be done right away. Instead, we configure a wait period of between 7 and 30 days before the deletion actually happens. From this level on, the wait is over. Deleting that key object happens immediately. Although for some AWS services, it's important to note there is a small wait for any cached keys to expire. This mainly affects services with high quantities of small data volume operations like S3 and SQS, which will cache unenveloped versions of the data encrypting key for short periods for performance reasons. And last but not least, Cloud HSM provides its own key usage auditing options, which from a compliance perspective enables you to trust but verify AWS KMS and AWS CloudTrail's reports on the usage of your keys. Let's look at the impact of this on our two critical questions. Key ownership is, of course, still with you when using Cloud HSM, with the side note that, of course, the KEK is still being generated and stored in AWS-owned hardware. As part of the Cloud HSM service, you have sole logical control over the hardware, but it's still worth knowing the ownership situation when discussing options with your compliance managers or legal department. How does this change the use case compared to CMKs? In addition to owning the generation and rotation of the key encrypting key, we now also get physically and logically private storage for it. This last point is the main thing to look for when choosing between CMKs and Cloud HSM. Cloud HSM really makes sense in that comparison when single tenancy is a hard requirement. But what if you need more control than just single tenancy? That's where our final option today comes in, XKS, External Key Store. This is the newest addition to the KMS options list and is by far the most complex to implement and operate. So in other words, it's like the big boss level of KMS. Let's dig in. So we start with the default KMS setup. DEC encrypts data, KMS generates KEK, KEK envelopes DEC in encryption. And now we introduce components outside of AWS. This is the external part of XKS, key management external to AWS. Meaning we need to provide a key management system ourselves, your own KMS, to work with AWS KMS. This can be accomplished using a proxy component to link your on-premise systems, or by purchasing managed HSM services from major suppliers. Once you have your key manager outside of AWS, you generate an additional key within it. This key will serve as an external key encrypting key, a second level of KEK, to encrypt the AWS-generated KEK in KMS. The result is a double envelope encryption. The DECs are encrypted and enveloped using an AWS-generated key, and then that AWS-generated key is itself enveloped and encrypted with your external key, which is a whole lot of acronyms and keys. So let's try to summarize this a little bit. With XKS, you have total ownership and control of the external key management system, meaning you also own and control the algorithms used to generate keys in it, which amounts to controlling the root of trust. The external keys never leave your external KMS, and thus AWS never sees them, as the enveloping of the AWS-generated key is done inside your external key management service. This does have significant cost implications, though, as with ownership comes responsibility. You are solely responsible for the ops of your external key management system. And if it goes down, AWS cannot perform decryption of any data protected by it. Thus, downtime of your external KMS equals downtime of your entire AWS environment, potentially. Ownership also begets observability. Being in full and sole control means you have absolute visibility over AWS's usage of your keys. So now you can audit usage entirely independently of AWS. And for the final time today, let's map this to our critical questions. You still own the key, specifically the external key encrypting key, which encrypts the AWS-generated key encrypting key from KMS. However, with XKS, the encryption system used for the data remains AWS proprietary, preventing us from decrypting the data outside of AWS. And from a use case perspective, there are two key requirements to look for: a truly independent auditing capability for key usage, and/or needing sole and exclusive ownership over that root of trust for your entire key management system. These two tend to go hand in hand, though, as it's quite difficult to prove absolutely AWS independent auditing of key usage without also owning the system storing the ultimate keys. There are, however, two additional things to be aware of when considering XKS, and the first is a hard technical requirement. Your external KMS must be no more than a 35 millisecond ping from your AWS region. This is due to the performance requirements for decryption operations in AWS KMS and equates to about a 1,000 kilometer maximum physical distance between your system and your chosen AWS region, which does mean that for European organizations, there's no way to have an external key management system in Europe controlling access to data in AWS US regions. But there is one final positive to XKS for European organizations. Of all the AWS KMS options, XKS is unique, to my knowledge, for having been featured in a court ruling about GDPR compliance. This was a French case where Doctolib, who store and manage healthcare data, were challenged for storing that data in AWS in Frankfurt and in Paris. The court found that Doctolib's usage of AWS to store sensitive personal data was GDPR compliant, and one of several factors that led to this ruling was that control of the encryption keys lay outside of AWS. Word on the street at the time was that Doctolib were using XKS in combination with Atos-managed hardware security modules. And so with that, let's turn to our Q&A section. Okay, so first question. Can AWS access my customer managed keys? So if you import a key material into a customer managed key in KMS, can AWS staff gain access to that key material? AWS are very clear on this. The answer is no. CMKs, like all keys in KMS, are stored in HSMs, hardware security modules. And HSMs are designed to prevent exposure of keys to anyone. Where can I get the proxy for XKS? There's an open source specification and a reference implementation for that on GitHub, but you do need to build your own proxy. It is not an out-of-the-box solution. Third-party managed services from big providers handle this for you, and you can just contract them to provide you with external HSM. And last but not least, can you import CMKs into Cloud HSM? The answer is no. All keys in Cloud HSM must be generated in Cloud HSM. And as it's a HSM, same as we just said for the CM keys, the keys will never be leaving that HSM. They can never be exported from it or viewed outside of it. So with that, I'd like to thank you very much for your time. If you'd like to contact us, you can reach out to us via our website or via any other channels, such as phone or email. We here at Fujitsu, we stand ready to support you with your cloud journey, and please reach out to us if there's any way we can support you. Thank you for your time, and have a very good day.